Hello everyone, today we are going to talk about chapter 10.5, rational numbers and irrational numbers. And in the previous session, we mainly talked about the Pythagoras theorem, right? Pythagoras theorem. In fact, the Pythagoras is a famous mathematician in the past. He has a school that many students follow him to learn mathematics. Also, he said one thing, that is, all things are numbers. In Chinese, it's called 萬物皆數. That means he thinks that all the numbers or all the things in the world can be expressed in the ratio of two integers, p over q. These two numbers, p and q, are all integers. And provided that, of course, q cannot be 0, right? Because when the denominator is 0, it has no meaning, right? And for example, I'll give you some example. For example, 7.5 is 15 over 2, right? These two are integers, right? 15 and 2. For example, negative 6, you can express in negative 6 divided by 1. Also, these two numbers are integers, right? So we can see, just like as it seems that all numbers in the world are numbers, can express in the ratio of p over q. But later on we know that it is wrong, so there is some story behind. I will talk about it later. And so in fact, what Pythagoras say that the p over q, this ratio is the concept of rational number. But of course later on we know we have irrational number. I will talk about it later. So today we are talking about which of the number we learned before is rational or irrational. We are going to distinguish between them. So first of all, we can see all the fraction, of course, is rational number, right? You can express in p over q. P and q are integers. Also, all the integers can be expressed in this format. So all integers are also rational number. So easy, right? Because any integers can be expressed by divided by 1, right? 4 is equal to 4 over 1 divided by 1 can be expressed in the rational number format. So besides these two common formats, we also have another two formats. That is the terminating decimals. In your book, it is on page 36. Terminating decimals, that means, for example, 1.2, negative 0.35. It has decimal number, but it is terminating. That means it is a limited number. That is only a number of decimal, not unlimited. Okay, so all these terminating decimal can also be expressed in the rational numbers. For example, 1.2 is, we know that we can change to 12 divided by 10, it is equal to 6 over 5, right? For negative 0.35 is negative 35 divided by 100. So simplify, we can get negative 7 divided by 20. Okay. So we know that terminating decimal is also one of the rational number. Okay. Then for the last one, that is the recurring decimal. That is, in Chinese is called 循環小數. For example, 0.33333, unlimited 3. Usually we use this symbol 0.3 dot. That means we are repeating the 3. Okay. And give you one more example. For example, 0.123123123123123. Okay. Then we use 0.123 the beginning and the ending. Okay, only these two dots, the beginning and this and the ending. So we are repeating 1 2 3 1 2 3 1 2 3. Okay, this one we repeating 3 3 3 3 3. Okay, and these two numbers can also be expressed in rational number. That is the fraction. That's ratio of two integers. For example, for 0.33333, we can express in 1/3. You can use your calculator to verify it. Okay, for this one 0.123123, in fact you can find that the answer is 41/333. Okay, and how can you find this number? In fact, you will learn it in senior forms about form 4. But if you are interested, you can Google it, or you can come and ask me directly. Okay, so we know that all recurring decimals are also rational number. Are all rational number. So that means now we have these four fraction, integers, terminating decimal, and recurring decimal are all rational number. So how about irrational number? It seems that all numbers can express in this format, right? In fact, the answer is no. For example, this chapter we mainly learn a new symbol, that is this one, right? The square root. The third form here, in fact, usually cannot express in rational number. For example, square root 2. When you use your calculator, you may find that the answer is about 1.41422222. Okay, and then you cannot change to any fraction. That P and Q are integers. And later, you may ask why? Because this one can be proved, but the proof is a little bit difficult. If you are interested, you may Google it, or also you may come and ask me directly. Okay, and later on I will tell you how can, besides using the memory about which one is rational, which one is irrational, I will also tell you how to use the calculator to distinguish which one is rational or irrational. So first of all, for most of the third form, it is irrational number. That means we cannot change to P over Q. Okay, but be careful. Some of the third form can change to rational number. For example, square root 4. We know that the answer, this one can be simplified to 2, right? And 2 is integer, right? Is integer. So this one will be a rational number. Okay, for those who cannot change to integer or fraction, then this one will be irrational number. Okay, also the second another number that you have learned which is irrational number is, for example, pi is also a irrational number. Okay, the 3.1415 something. Okay, and later on in Form 2, Chapter 12, you may learn something like sine, cosine, tangent. Some of you may heard about it. And some degree of this trigonometry are also irrational number. Okay, for example, sine 29 degree, sine 31 degree are all irrational number. But some of the value are also rational. For example, sine 30 degree, in fact it is 1/2, and we know that 1/2 is fraction, right? So it is irrational. But these two cannot change to fraction, so this one is irrational. Okay, so just memory, third form, pi. Okay, mainly these two, and later on you will learn these three. Okay, then I'm going to talk about another properties about the rational number and irrational number. First of all, I'll show you the photo. Okay, and in fact this one you can find it on your book, page 37. Okay, and it says that for any two numbers about the calculation for plus, minus, times, or division. When two numbers are added together, if both of them are rational, then the outcome will be rational, right? For example, 3 plus 1 over 2, we know that the answer will be 3.5, so you can change to 702, right? So for subtraction, also correct. For multiplication, also correct. For division, also correct. That means if both of them are rational, then whatever you do, the operation, you also be rational. Okay? For the second point, if one is rational, another one is irrational, then the operation for any plus, minus, times, or division are also irrational. For example, pi plus 2, this one irrational, this one rational, then this one will be irrational number. Okay? But be careful, the a must not be 0, because you know that 0 times anything will become 0, right? 0 times square root 3 will also be 0, right? Then it will become rational, right? 0 is rational because we know that, oh, sorry, the pencil has some problem. We know that 0 can be expressed in 0 over 1, right? Okay. Also, this one, for the second point, is one is rational, another one is irrational. How about both of them are irrational? Usually, both of them are irrational number, the operation usually may be irrational too, but sometimes it may not. For example, there is a point, for example, these two. You can see when two numbers are added together, sometimes may equal to a rational number, for example 0, okay? But sometimes it may also be irrational. Usually, most of the times, usually is irrational, usually, okay? But I'm going to tell you how can we check the number by calculators, okay? So I'm going to show you the calculator. Okay, and I think some of the students may heard about this before. That's how can we change the answer to become a fraction by using the calculator. For example, 14 divided by 5, we know that the answer is 2.8. But when we want to change to fraction, how can we do? First, we should press the shift, okay, shift. You can see there is an icon here, S, and then we press this one, A, B slash C, this one, press, and then you can see the answer is 14 divided by 5, right? Okay, I give you one more example. For example, negative 2.15, 13, and then again shift, and then A, B slash G. You can see the answer is negative 213 divided by 100. Okay, you can use this method to find any one that we have learned. For example, we have learned about the recurring decimal, right? 0.33333. When we press many 3 here, and then we put shift, and then this one, you can see the answer is 1 over 3. It still work. Okay. For example, 0.123, 123, 123, 123, 123, 123, 123. Oh, sorry, this one. Okay, and then again shift, and then this one. You can see we can get the answer. Okay. How about for the third form, for square root 3? This one, shift, and then this one. You can see no change, right? Cannot change to any fraction. No change, right? And then for example, pi here, shift, and then this one, and then we shift, and then this one, no change also, right? So we can simply use this one to check whether the number is rational or irrational number. But this method usually it is correct, but it is not 100% correct. For example, sometimes when the fraction, the denominator and the numerator are very large, then it cannot show you. For example, 1 2 3 3 2 1 1 2 3 divided by 1 3 1 1 1 3 1 1. this one, and then you press the number, you can see you cannot change to any fraction. But you know that this one must be a fraction, right? Because it's a division. Because the numerator and denominator is very large, so the calculators cannot show just the case because of this. Okay, but you can see this method can help you that when the numbers can change to fraction, it must be a rational number. If the number cannot change to a fraction, it has a higher chance that it is not a rational number. It has a higher chance that it is irrational. Okay. So I'm going to talk about this session maybe a little bit. There are many things to tell you. I'm going to talk about the last thing. Talking about the rational and irrational number, usually you must talk about famous stories. That is, why the Pythagoras later on will have known that there is irrational number in this world, and there is a famous story about some people find the truth, and then you can see that he is being put into the water. And also there is some famous terms. There is first crisis in mathematics. In Chinese, it is so-called 第一次危機. Okay, if you are interested, you may Google it or come and ask me. I'm not going to tell much about it. So in this section 10.5, there is last part that is about the part C. Part C is going to ask you to represent an irrational number on the number 9. In Form 1, we know that we can mark the numbers on number 9, but how can we mark a irrational number? For example, square root 2, square root 3, or etc. I'm going to talk about it roughly, because mostly in examination you will not ask you to do this kind of question. So I'm going to talk this faster. Okay. For example, this one. And we know that for a right angle triangle, we can use Pythagoras theorem, right? So if this one is 1 unit, this one is 1 unit, and then OP, we know that it is 1 square plus 1 square is 2, right? Then OP, taking about the square root, we know that the length of OP is square root 2, right? So we can get the length of OP. This one is square root 2. Then how can we mark on the number 9? We should use the compass, 圆規. That means we can put a compass here to mark the length of square root 2, and then we rotate the compass to mark the corresponding length on this one. Then we know that this point, the length of this one is square root 2. Okay, understand? So that means for any set form, that is the square root something, if we know how can we express the number inside the set form, for example, square root 29, we know that 29 is equal to 5 square is plus 2 square, then we can mark square root 29. 5, 2, and then 5 square plus 2 square is 29. So this one is square root 29. So again, use the compass and mark here. Some of you may say, oh, do we need to do the homework at that or exercise that we do this kind of thing? Yes. Then some of you may say, oh, I do not have the compass. Then you should go and buy it, of course. But if you really don't have it, I have already tell some of my classmates that how can we use 2 pencils to make a simple compass. And if you're interested, you may come and ask me. But I strongly advise you to buy a compass. Okay. So for how we do the exercise, I will talk about it in the next video.